Hello friends, welcome back to our channel. In this video, I am going to explain deletion of an element in a circular queue. At the end of this video, you are able to understand what is a circular queue, what are the circular queue operations, and the algorithm for circular queue deletion. Circular queue is nothing but a linear data structure which follows first in, first out principle. It has two ends, front and rear. Always insertions will happen at rear end, deletions will happen at front end. We have some problem with linear queue when deletions. The problem here is I have a queue like this with 6 number of elements. I have deleted all the elements at front side. Now front is pointing to 5th position. If I delete this front position, the queue will become empty. So some cases, if I have some elements on the left side, so you can still get this front pointer to the 0th position. This is possible. If we get this front pointer from last index to the first index, then it is called a circular queue. So we'll see with this an example. Here I have a circular queue. The positions of rear and fronts are like this. Now front is pointing to the 5th position. I want to delete one element. If I increment front, so the front will point to 6. There is no index position 6. So now we cannot move this front to the beginning in the case of linear queue. But if it is a circular queue, then we can get front position to index 0. This is possible in circular queue. So now I have changed the index of front max minus 1 to index 0. Now front is pointing to 0. Now again we can delete the elements from the front. You can delete 10, you can delete 20 and so on. We'll see these details. There are mainly three operations of a circular queue: enqueuing, dequeuing and displaying. Enqueue means inserting an element, dequeue means deleting an element, display means printing the elements inside a circular queue. To perform a deletion operation in a circular queue, you need to understand two basic steps. Those steps are, we have to assign queue of friend to a temporary variable. The temporary variable here is deleted item. I want to display which item is deleted, so that I am storing the queue of friend to a temporary variable. So then I will increment front to front plus 1, so that front pointer is moved every time by one position. If it is a circular queue, we have to concentrate on these three conditions. The first condition is, if the queue is empty, how the logic you are going to write? If front reaches to max minus 1, so what is the step you are taking? If front equal to rear, what you are going to do? These three steps or these three conditions are must be presented in the circular queue algorithm. Now we will see this with an example. Consider a queue of elements. The max size is 6 here. We can store 6 number of elements. Initially I have assigned front equal to minus 1 and rear equal to minus 1. It indicates that circular queue is empty. Now we don't have any elements in this queue. If I ask dequeue operation on this queue, there are no elements. If there are no elements, it has to display a message that queue is empty. My logic, I am starting here. If front is equal to minus 1 or rear is equal to minus 1, print queue is empty. There are no elements inside the queue. That's why front is pointing to minus 1 and rear is pointing to minus 1. This condition is true now. It will display queue is empty. This is the first condition we have discussed earlier. If queue is empty, just print a message that there are no elements inside the queue. That's why queue is empty. What is the condition here? If front is equal to minus 1 or rear is equal to minus 1. This is the condition. Then if I have elements in the circular queue, then the logic will be updated. So we'll see here, I have a queue of elements like this. Front is pointing to 0 and rear is pointing to 5th position. This is max minus 1 position. Now I want to delete one element, dequeue of one element. So how can we do this? Check this condition if front is equal to minus 1 or rear is equal to minus 1. So now this condition is false. Why? Because front is pointing to 0. This condition is false. Now we'll come to the else block. We have to perform two basic steps. Queue of front. Here queue of front is 0. That is 10 will be stored in a deleted item. 10 is stored in deleted item. Later, front is incremented by 1. Front is equal to front plus 1. So here, just assign the queue of front to deleted item and increment the front. So now front value will become 1. One item got deleted. I want to perform dequeue again. So again, this logic will be applied. Front equal to minus 1 or rear is equal to minus 1. This condition will become false. So now deleted item is equal to queue of front. Front is now 1, queue of 1, 20 will be assigned to deleted item. Then front is incremented by 1. Now front will move to the next position. So now this logic will do increment of front by 1. So in this way the elements will be deleted with this logic. So meanwhile I have two empty locations. I will insert some elements in this position also. So I am enqueuing here enqueue of 70. Enqueue of 70 with circular queue insertion algorithm, we are inserting 70 here. Now rear is pointing to this position. Then I am enqueuing of another element, enqueue of 80. So 80 is storing in queue of 1. So now rear is pointing to the first position. I am not explaining any enqueue operation. If you want to know how to insert an element into the circular queue, you watch my previous video. Now our task is I want to delete elements. So now continue our deletion algorithm. So I want to dequeue of 30. So the same logic here, if front is equal to minus 1 or rear is equal to minus 1, condition become false. Now it will store queue of front to deleted item. Front is incremented by 1. So front is moved to here. If I apply dequeue again, front is moved to one position. If I apply dequeue again, front is moved to another position. So now here we have to update our logic. So if I want to dequeue on this queue, front is pointing to max minus 1. So now check this logic. Front equal to minus 1 or rear is equal to minus 1 false. Deleted item equal to queue of front. 60 will be stored in the deleted item. Front is equal to front plus 1. Now front will become 6. There is no index of 6 here. So what we have to do, whenever this front reaches to max minus 1, you have to assign front to the 0th position. This is the concept of circular queue. So we can move this front to the first index, that is 0, when front reaches to max minus 1. So you see here updated logic. Before this else I am adding if front equal to max minus 1, then front will become 0. So this condition is true. So I am resetting this front to 0th index. So now front will become 0. So now front will become 0. One item got deleted and front will become 0. Now I want to dequeue operation again. So here again front is now 0. So when front is 0, then this logic applied here. Front equal to minus 1 or rear equal to minus 1, condition become false. Queue of front, that is 70, will be assigned to deleted item. Now front is not max minus 1. So now just increment the front value. So front will be incremented by 1. Up to now there is no problem. Now we have front and rear pointing to the same position. That meaning is we have only one element inside the circular queue. If I delete this 80, that means front is moving to the next position and now circular queue will become empty. So we will add this logic also inside the circular queue deletion algorithm. When front and rear pointing to the same position, if I delete, I will check this if front equal to rear. So now I will assign front to minus 1 and rear to minus 1. This is the starting initialization again. So the circular queue is empty. So again we can do some insertions and deletions in a later point of time. I will update this logic. Here I am adding else if front equal to rear, I will update front to -1 and rear to -1. This is -1 here. The queue status will become something like this that we have seen in the first stage. Again, if I want to dequeue here, now front is -1 and rear is -1, the circular queue is empty. That message will be displayed. This is the complete algorithm we have. Whenever you want to delete an element inside a circular queue, first check the condition whether front equal to -1 or rear equal to -1, print a message queue is empty. Otherwise, we are doing these many steps. I am assigning queue of front to deleted item. Every time I am checking whether front reaches to max -1. If front is equal to max -1, then only we will assign front to 0. In addition to this, we are checking whether front is reached to rear. Front equal to rear. If this is the case, we will assign front to -1 and rear to -1. Otherwise, we will increment the front pointer by 1 every time. We have another alternative ways also. So consider I have initialized rear to -1 and front to -1 in this example. You can also initialize rear to 0 and front to 0 and work on it. And for incrementing, I am taking front is equal to front plus 1. Whenever I reached front to max -1, at that time I am resetting front to 0. Instead of writing these two lines, so you can also use front equal to front plus 1 modulus of max. Here max is the number of elements. So by this statement, we are incrementing the front pointer every time. This is a simple logic about deletion of an element in a circular queue. If you have any queries, please comment in the comment section. Thank you for watching.